I'm in my civilian clothes, so maybe I should dress up actually and play around with some video editing. So there we are. Too much? Yeah, it's too much. You're right. Here we go. Perfect. Okay. See how seamlessly I can edit that together. All right, let's get started. So, talking about chapter 5, which is all about rational expressions and equations. So, like we were talking about last time, rational means fraction. That's all it means. Truly, we're just talking about fractions and putting some kind of like complex algebraic stuff into them. So, last time we was talking about, just some kind of like simplifying work. Like 2x divided by 4x plus 6. Stuff like this. You might be asked to simplify this. You might be asked to find the restricted values of this. If this was written using function notation as a function, you might be asked to find the domain of that function, which is to say to find the restricted values and then take everything else that can work. Things like that. Also, you can take rational expressions, multiply them by other rational expressions. Stuff like this. And like we were talking about last time, this really just amounts to multiplying two fractions together. This is a fraction, multiply those two fractions together. To do fraction multiplication, you multiply the tops and you multiply the bottoms. Although, when it comes to algebra, I think the best thing to do is to factor everything, always. This is just something that I always do. You factor everything and then kind of make a judgment call at that point. It's kind of like a pre-simplification, if you will. So I'll just demonstrate here on this one. What I would do here in this case to multiply these together is the first thing I would do is, and I'm just going to write this really explicitly, like 2x is 2 times x. So, it's not technically needing to be factored, but I'm just like writing it as its constituent parts. This right here, 2 can be pulled out. So you can write it as 2x plus 3 multiplied by 6 times x divided by 3 can be pulled out, 2x plus 3. Right, so I've just factored everything. And in fact, look, you even take this further and write the 6 is 2 times 3. So that's prime factoring, which I'll talk about here in a minute because it is very helpful with some more of this kind of stuff. So everything's factored. That's all I've done there is factored everything. But now you can see that there's some cancellations that can be made. There's 2 on the top here and on the bottom. Here there's a 3 on the top and the bottom. And that's it. That's all that can be canceled, right? You can't cancel this 2x plus 3 with this 2x plus 3 because they're both on the bottom. You can't cancel this x with this x because they're both on the top. So that's it. That's all that happens. Now you can just like evaluate what's left over. On the top you have x times 2 times x, which is 2x squared. And on the bottom you have 2x plus 3 times 2x plus 3, which if it were me I would write that as 2x plus 3 squared. And there you go. Fully simplified. Great. Okay. If it was a division sign, we talked about last time too, really it's not that much different. You just get an added step at the beginning. This is what I do. If it's 2 rational expressions being divided by each other, first thing you should do is keep, change, flip. Then just treat it like a multiplication problem. The way that you multiply 2 fractions together is multiply the reciprocal of the right hand, of the one that's on the right. Right? So you change this to multiplication, and you take this reciprocal, run it as normal. Sweet. What's coming up next is addition and subtraction of rational expressions, which I think is just objectively harder. And I've got some things that you really should practice from pre-algebra again that I think will make it easier. So I want to run through those really quick. But just to refresh your memory, fraction addition is something like this. And in order to do this, you absolutely have to have the same denominator. You can't do it if the denominators are different. Right? So you have to do this process called finding the common denominators. And that's a whole thing. You know, people have different ways of doing that. But I'm going to show you like a really specific way of finding the lowest common denominator. And also, I wanted to cover you to review this idea that you can change a fraction any way that you want. It's almost like anti-simplifying, right? So just let me back this up for a sec. This is the type of thing that we want to be able to do. But let's just take a look at like 1/2, for instance. If 1/2 was written as, say, like 4/8, normally what you'd do is you'd simplify this. And what we were talking about last time is like to simplify that, you could factor 4 into 2 times 2. And you could factor 8 into 2 times 4. And I mean, even, you don't even have to use 2 here, sorry. So like, you could factor 4 into 4 times 1 and 8 into 4 times 2. Right, and then these 4's cancel. Cancel, what that really means is that this can be written as 4 divided by 4 multiplied by 1 divided by 2. And 4 divided by 4 is actually the number 1. So that's 1 times 1/2. And 1 times anything is just the thing. Right? So it really just works its way down to be 1/2. But underneath the hood, so to speak, this is what's happening. You're factoring out something that when divided by itself makes the number 1, and the number 1 multiplied by anything doesn't change the thing. So you effectively can just, if you have something on the top and the bottom, get rid of it. That's what canceling is. The point I want to make is that you could run that in reverse. Right? If you have 1/2, you can multiply it by the number 1. The number 1 can be written as anything divided by itself. Then you can multiply the thing through on the top and the bottom. So you can anti-simplify, you know? And you'd want to do that so that you can force things to have common denominators. So if you go back to 1/2 plus 1/3, you do anything you want to either one of these fractions. Like, look, this is 2 fractions. This is a fraction, this is a fraction. I can take 1/2 and multiply it by 3/3, which is the number 1. 3 times 1 is 3. 3 times 2 is 6. Right? So 3/6 is the same as 1/2. I just unsimplified it, you know? I took it out of its most reduced form. Because that's going to suit what I want to do. 1/3, I can multiply that by 2/2. Because 2/2 is the number 1. 2 times 1 is 2. 3 times 2 is 6. Boom. I've just forced them to have the same denominator. So in order to add fractions, you absolutely have to have the same denominator before you can do it. And you'll always be able to do that by finding the lowest. I mean, you should find the lowest common. You don't need the lowest common denominator. You just need a common denominator. The lowest common denominator turns out it's going to be really beneficial to use the lowest common denominator. So I'll show you how to do that, how to find those. Once you have common denominators, you just run the addition on the numerators. So this is like 3 of these plus 2 of these is 5 of these. Really common mistake, you know, that if you're not working with fractions for a while is to just add the tops and add the bottoms like you would do with multiplication, but that's wrong. With addition, you just add the tops. Once you have the same denominator, you only run the operation on the top. Right? So it's 5/6. That's how that works. Once these get more complicated, finding the lowest common denominator can be challenging. The thing that makes it a lot smoother, and this process that I've come to believe is the best way to do it, is to use prime factorization. So if you don't remember prime factoring, it's a way that you can factor numbers into a bunch of prime numbers multiplied together. So let me just change these numbers here a bit to make this point. Let's say 1/4 plus 1/10. This is two fractions added together. If you're going to do this, absolutely need to have common denominators. They're not the same right now. 4 is not the same as 10. So you got to force them to be the same by multiplying this fraction by something and multiplying this fraction by something. Same thing on the top and the bottom again. What you should first do is identify what thing is shared between 4 and 10. The smallest thing that's shared between 4 and 10. So it's called the lowest common multiple, the least common multiple. A lot of times, it's just, you can just think about it. So it's 20. Like, I'm just looking at this, it's 20, right? Because 4 does not go into 10, so it's not 10. The next multiple of 10 is 20, and 4 does go into that. So the smallest thing that they both share is 20. The smallest thing that the smallest multiple of both 4 and 10 is 20. You can figure that out without having to just look at it using prime factor, right? So here's how it works. Prime factor both 4 and 10. This is how I like to do prime factorization. 4 is 2 times 2. Both 2 and 2 are prime, so that's the prime factorization of 4, 2 times 2. Over here, 10 is 5 times 2. Both 5 and 2 are prime, so that's the prime factorization of 10. Once you have both numbers prime factored, this is what you do to find the lowest common multiple. Figure out what's shared. If there's a number that's shared, if there's a prime that's shared between both, identify it. So 2 and 2 is a shared prime factor. And I just like to write it like this. So you get a 2. Each one of these has a 2, so you get a 2 that's shared. I like to cross them out now because I've used that up. Keep doing that, identifying all the pairs, all the things that are shared. So if there was another 2 and another 2, then you get one extra 2. If there was a 5 here and a 5 here, you get a 5 here. All right, that's the only thing that's shared. So now what you do is you take everything else. There's another 2 here, so you take that. And there's a 5 here, so you take that. Now you just multiply all these numbers together. 2 times 2 is 4. 4 times 5 is 20. So there you go. That's how you identify the least common multiple. So look, this is that's kind of like number theory here. This is really it's just a really like number theoretic way to find the lowest common multiple, which turns out can be applied to be the least common denominator, lowest common denominator. The reason I'm telling you about it is because I think it's going to be really helpful once all this changes to algebra. To think about it this exact same way. Right, so just to finish this up, now that you've identified the lowest common denominator as 20, what I like to do is do a little bit of setup work here. So I'm going to just write, 20 plus blank. Blank over 20 plus blank over 20. I know that I'm going to turn this into something divided by 20, so you need to figure out how to make this into 20. And to do that, you multiply it by 5. If you're going to multiply by 5 there, you got to multiply by 5 here. So that's what you're going to do. So it becomes 5/20ths. And you can see that 5/20ths is the same thing as 1/4. Here, you're going to turn 10 into 20. In order to do that, you multiply by 2, but you have to do it up here as well. So it becomes 2/20ths. And you can see that 2/20ths is the same thing as 1/10. So I've anti-simplified both 1/4 and 1/10. In order to suit what I'm trying to do, which is to combine these two fractions using addition. So this ultimately becomes 5 plus 2, which is 7/20ths. Now, a lot of times when you're done with addition or subtraction of fractions, you just want to take a minute to be like, is that fully simplified? Is there any other simplification that could be done once you've done the operation? Nope. Okay, cool. So that's your final answer, 7/20ths. Awesome. Yeah. Right, so using just numbers like this is, I think, really helpful because when it turns into algebra, it becomes a bit more difficult. So let me give you one to try. Try 1/18 plus 3/42. Pause the video if you want to give this a go. I'm just going to work it out right now. So what you should do is recognize that this is two fractions being added together. In order to add two fractions together, have to have common denominators. So the very first thing you need to do is force them to have the same denominator. This is always possible, by the way. It's never impossible to get common denominators. It is always possible to do it, even if these two things didn't share, didn't have something. I mean, there's always going to be a smallest thing that they share if you just multiply them together. I'm sorry. There's always going to be a thing that they share if you just multiply them together. But sometimes there is an even smaller thing that they share, and that's the lowest common multiple, lowest common denominator. That could be difficult to find. In this case, I don't know. I wouldn't know just looking at this. I'd have to stare at it for a while. So what you should do is use prime factorization. Prime factor 18 into 9 times 2. Then 9 is 3 times 3. And then I just pull this 2 down. So 3 times 3 times 2 is the prime factorization of 18. Prime factor 42. 42 is 7 times 6. 6 is 3 times 2. And I just pull the 7 down like that. 7 times 3 times 2 is the prime factorization of 42. Once you have the two things prime factored, identify, pairs. So look, I have a 3 here and a 3 here. So you get a 3. They both have a 3, so you take a 3. This can be kind of confusing sometimes. You don't take 3 times 3 when they both have it. If they both have it, then you just get one of those. Cool. So I like to kind of I've used that pair. They both have a 2, so you get a 2. I've used this. Once you've identified all the things that are shared, take everything else. So this 3, you got a 3 here, and you got a 7 here. Three times 2 is 6. 6 times 3 is 18. 18 times 7, can't do in my head, 126. So 126 is the lowest common denominator of 18 and 42. Once I've identified that, I do a little bit of setup work. Go like this. Right, I'm going to force this fraction to have a denominator of 126, and I'm going to force this fraction to have a denominator of 126. Don't know what the numerators are going to be yet, because I got to figure out first how to make this into 126. So 126 times what is, 18 times what is 126? 7. So you would multiply this by 7 over 7. 42 times what is 126? 3. So you'd multiply this by 3 over 3. Right? So this results in 7 1/26 and 9 1/26. Now you can add these two fractions because they have the same denominator. 7 plus 9 is 16 126. So, like I was saying, just to be completely done with adding fractions, you should always take the final combined result and say, can it be simplified further? And this one can. Right, 16 and 126 are both even numbers, so you can divide them both by 2. 8, 100, and, I can't do 126 divided by 2 in my head. 126 divided by 2, 63. 8 63rds. 8 63rds. I don't think that can be simplified anymore. There you go. That's how you do it. Right, so this is a process. It's a total process, and it's really worth the practice to get this dialed. Because when all of this becomes algebra, it's just a bit more abstract. But really, it's going to be the exact same process. you're just going to use the factoring that we've been talking about rather than prime factoring of numbers. All right, so let me give you an example of that. Take a really similar one with algebra. So like, how about 1, 3x plus 6 plus 4, 2x plus 4. Make sure this is recording still. Right. So again, it's just two fractions added together, right? This is a fraction added to another fraction. Sweet. So in order to add fractions, you absolutely have to have the exact same thing in the denominator. And you don't right now. These are two totally different things. So first thing you should do is identify the lowest common denominator of these two fractions, which really just amounts to factoring. Just factor both of them. So this is what I would do. Write this as 3x plus 2. Write this as 2x plus 2. Now you can run the same process, right? Let me just, so this one here, you can say the prime factorization of this. I mean, I don't really want to say prime factorization because, that in that context that means numbers. But the factorization of this is two things: 3 times x plus 2. The factorization of this is 2 times x plus 2. So you can identify the things that are shared, just like you were doing before, and that's x plus 2. So you get an x plus 2. Once you've identified all the things that are shared, get everything else. So you get a 3, and you get a 2. Multiply all this together, and you get 6x plus 2. Right, so 6x plus 2 is the lowest common denominator of 3x plus 6 and 2x plus 4. I hope you can see that that's, it's the exact same method, really. You just replace prime factoring with algebraic factoring like we've been talking about. So do the same exact thing, do a little bit of setup work here. I'm going to do blank divided by 6x plus 2 plus blank divided by 6x plus 2. Now you need to turn this into 6x plus 2. I'm going to work from here. I like to go from the factored forms. So in order to turn 3 times x plus 2 into 6 times x plus 2, you just multiply it by 2. But you also have to do it on the top. In order to turn 2x plus 2 into 6x plus 2, you multiply it by 3. Now you just run it. 2 times 1 is 2. 6x plus 2. 3 times 4 is 12. Now you can combine those two fractions because you have the exact same denominator. 2 of these plus 12 of these is 14 of these. There you go. But again, you should take a minute and say, like, okay, can that be even more simplified? Yes, you can. 14 and 6 are both even numbers, which means you can pull out 2. So 7 divided by 3, x plus 2. Right, just to kind of further explain that. 14 can be written as 7 times 2, and 6 can be written as 3 times 2, and you can get rid of these 2's. So this is your final answer. 7 divided by 3 times x plus 2. Which, if you want to, is totally fine to write that as 7 divided by 3x plus 6. Right, you can distribute this 3 if you'd like. I prefer to keep it in the factored form. It's just, like I was saying last time, I find it to be more useful. If I'm gonna go forward and use this to do anything, I like to leave it in my factored form. So either one of those is correct. I mean, you could box either one of these. Awesome. All right. One thing I want to draw your attention to is that there's another strategy that is nice to keep in mind when working with fractions, and that is to, at the very beginning, before you even start, to pre-simplify, if you can. And in this case, you could have. Let me get rid of all this. I'm just going to leave the answer. This fraction right here could have been simplified from the get. Right? It's usually beneficial to do that because it just makes all your calculations smaller, and it makes it easier to find the lowest common denominator, and it makes the simplifying at the end much cleaner. So if I were you, I'd watch out for that. If you're able to simplify a fraction before you even start, you should do that. Right? So 4 can be written as 2 times 2, and 2x plus 4 is 2 times x plus 2, and you can get rid of one of these 2's. Right, so from the start, you could have written this as, I'm going to factor this again, 3x plus 2 plus 2 over x plus 2. Usually when I'm working with fractions, if I have something like this, I just bracket it just so it looks like, just to make it clear to myself that that's a factor, right? It's its own unit. So I like to put brackets in there even when it's unnecessary. Right, now, if you're going to add these together, again, same process, you need common denominators. So you should find the lowest common denominator using that factoring process. Right? The factors of this one are 3x plus 2, 3 times x plus 2. Factors of this one is just, 1 times x plus 2. Well, just x plus 2. So you take the pairs, and then you take everything else. So the lowest common denominator here is 3x plus 2. So I'll do a little bit of setup work. Whoops. As usual, this one doesn't need to be changed though. It's already 3x plus 2, so you don't have to do anything. Cool. This one, in order to make it 3 times x plus 2, you multiply the top and bottom by 3. So you get 3 times 2, which is 6. Now add them together and you get 7. Same exact answer. A little bit less calculation to get there though, which I think is a beneficial move. Cool. Right, that's how you do it. All right, let me give you one to try here. How about this? Here's a kind of x minus 2y divided by x minus y. Oops. Plus x plus 9y divided by x minus y. So these are going to start to look pretty nasty. I mean, this one's marginally nasty, but make sure this is recording. Sweet. The thing, the mantra that I repeat is, if you're going to be adding two fractions, this really is just a fraction plus another fraction. If you're going to do fraction addition, you have to have common denominators. So that's the first thing you should look for. You do have that right now. So you can just go for it. Okay, back at it. So yeah, this one already has common denominators. So there's nothing for you to do. You can just get to adding. So you just do the operation on the top, right? So this just becomes x minus 2y plus x plus 9y all over x minus y. It's this plus this over the common denominator, which is x minus y. But now you have some combining to do. X plus x is 2x. Negative 2y plus 9y is 7y. X minus y. There you go. And then there's nothing else you can do. I mean, again, normally what you would want to do is take a second and say, is there any other simplification that can be done here? If no, then move on. So no, there's nothing else that can be done here. I do want to change this slightly to make a point, if I can do that. Yeah. So this is the answer to the problem. But, you know, if I here's a new problem for you. Let's say this. How about that? Yeah, that's a really. Oh well. Okay, this is a super weird problem. I just want let me do this, and I'll make the point that I want to make. So you have a fraction plus a fraction. They have common denominators, so you can just do the operation on the top. So it's x plus y plus x plus y over x plus y. This plus this over the common denominator. Again, you have some simplifying to do here. You can on the top do x plus x, which is 2x, y plus y, which is 2y. And then I was just saying, now that you've done the combining, you should look and say, is there any more simplifying I can do? In this case, there is. So on the top, 2x plus 2y can be factored. Pull a 2 out. And now you can see you have an x plus y on the top and an x plus y on the bottom. So those go away, and you just get 2. So this just simplifies to the number 2. The reason I'm saying that's such a weird problem is because, I mean, maybe you could see that it's just 2 if you look up here. X plus y divided by x plus y is 1. X plus y divided by x plus y is 1. 1 plus 1 is 2. Right? But this process is good practice to, you know, to run it like this, because this is going to happen a lot where when you combine it, you have the result of the addition, but then that result can maybe be factored and maybe be simplified a lot more. So you should be on the lookout for that. Sweet. All right, so let's do one with some bigger factoring problems. How about 9x plus 2 divided by 3x squared minus 2x minus 8 plus 7, 3x squared plus x minus 4. Make sure I wrote this down right. Minus 2 minus 8 plus 4 minus plus x minus 4. Good. All right. Good. Right. So look, it's starting to get pretty. I mean, I think this is objectively a pretty complex algebraic expression. But if you just really boil this down, it's a fraction plus a fraction, just straight up. Fraction plus a fraction. So it's no different than 1/2 plus 1/3 in a sense. In order to do a fraction plus a fraction, you have to have common denominators. You don't, so you need to force them to be common denominators. So the first thing you should do is identify what the lowest common denominator is, do some setup work, force them to have common denominators, do the addition, then check to make sure that you can simplify that result further if you can. So it begins with just factoring. Factor everything, always, and then run the rest of the process. Right? So 9x plus 2 cannot be factored. 3x squared minus 2x plus 8 probably can be factored. You'll get 3x and x. Oh boy. I can't do that on the drop of a hat. 7 can't be factored. 3x squared plus x minus 4 can be factored. Same deal, you get 3x and x. Fast forward the video when I get this worked out. Yeah, I just like to try things in my head, you know. So 8's going to be 4 times 2 or 8 times 1, 12, 6, and 4. Yeah, here we go. So it's going to be 2 and 4, but not plus and plus. You're going to have minus 4 plus 2, right? Because that's going to be 6 minus 4. Nope. It's going to be negative 6 plus 4, which is minus 2. That's going to be minus 8. Cool. This one here, 4 is 4 and 1, or 2 and 2. 4 and 1 is probably going to be the case. 3 plus 4 minus 3 is 1. You get a negative 4. Great. Okay, cool. So there we go. That's factored up. Now that you have these two things factored, you can run this process in order to find the lowest common denominator. So this one has these two factors. It has a 3x plus 4 multiplied by an x minus 2. And this one over here has two factors. It has a 3x plus 4 and an x minus 1. So identify the ones that are the same. 3x plus 4, and you get a 3x plus 4. So I've just used that up. Now, if nothing else is the same, take everything else. So you get this x minus 2, and you get this x minus 1. So here is the common denominator. 3x plus 4 times x minus 2 times x minus 1. I mean, you know, sometimes common denominators are long and ugly like that. And look, here's another point. You could multiply all this out, right? You could FOIL these two, and then your resulting trinomial, you could multiply by this binomial, and you'll get a polynomial. I just don't find that super useful, right? It's I just think that it's been more useful in my experience to leave polynomials factored if they're factorable. So I would just leave it like this. So now do your setup work. Kind of running out of the room here. But you know, you're going to get blank over 3x plus 4 times x minus 2 times x minus 1 plus blank over 3x plus 4 times x minus 2 times x minus 1. So now you need to ask yourself, how do you turn 3x plus 4 times x minus 2 into 3x plus 4 times x minus 2 times x minus 1? And the way that you do that is by multiplying by x minus 1. But you also have to do that on the top. So on this side you get x minus 1 times 9x plus 2. Now how do you turn x plus 4, 3x plus 4 times x minus 1 into 3x plus 4 times x minus 1? Well, you just multiply it by x minus 2 on top and bottom. So on this side you get 7 multiplied by x minus 2. So technically, this is the answer. Oh, look, sorry. Now you have to actually do the addition. Unbox this. Now you have to add just the tops. Right, so it ends up looking like this. X minus 1 multiplied by 9x plus 2 plus 7 times x minus 2 all over the common denominator, which is 3x plus 4 times x minus 2 times x minus 1. Technically, this is the answer. Although that can definitely be simplified more. That is those two fractions combined, though. Right? Like if your task and you're only, you know, interested in taking these two things and combining them into one thing, boom, you've done that. It's just, you know, like I'm sure you're used to by now, you should simplify fractions as much as possible. Simplify everything as much as possible. If you're doing something algebraically, take your result and make it as simple as you possibly can before you report it or use it for something else. So we got some more work to do here. So I'm going to get rid of some of this. the work that you should do is on the top. So I would FOIL those first two things, distribute that 7, combine like terms, and then see what's happening. So x minus 1 times 9x plus 2 will be 9x squared plus 2x minus 9x, which is minus 7x minus 2, and then plus 7x minus 14, all over the common denominator, which I'm going to leave alone. I'm not going to FOIL this out. Seven x plus 7x goes away. Negative 7x plus 7x goes away. And then 14 minus 2 is minus 16. Okay, so there's where you're at. Still not done. And the reason is because this is a difference of squares. So this can be factored. This, to write this as a difference of squares, recognize that 9 is 3 squared. So it's 3x all squared, and 14 is 4 squared. So I'm just going to factor this in place. 3x squared minus 4 squared becomes, using a difference of squares, 3x plus 4, 3x minus 4. And now, finally, you can see that you have a 3x plus 4 on the top and a 3x plus 4 on the bottom, so those get eliminated. Final result, 3x minus 4 divided by x minus 2 times x minus 1. That's your final, simplest form answer. So that's a really good, I think, representative problem on just kind of like the complexity of some of these algebraic rational expression addition problems. It really brings a lot of things together. You know, you gotta have factoring dialed. You gotta have fraction addition dialed. You gotta like be on the lookout for things that can be done once you've done all these things. And yeah, this is really like this type of problem I think can really advance your algebraic skill a lot if you practice it. So yeah, put a bunch of those in the homework. I haven't really talked about the subtraction problems that much. It's the same exact thing, you know, you need common denominators to do fraction subtraction. It's just you subtract the numerators rather than add. So let's do one more and we'll call it a day. Let's do got this, x divided by x squared minus x plus 20 plus 2 plus 4. X squared minus x minus 20 plus 2 divided by x plus 4. All right, give that a go. Right, so it just says add these two fractions together. You can pause the video if you want to give it a try. I'll just work it out right now. So again, just run the process. You know, like I like to kind of just talk out the entire process in my head when I'm doing these things. It's two fractions added together. In order to add two fractions together, you need common denominators. You don't have common denominators. In order to find common denominators, use factoring, and then use this process to, you know, find the pairs that each factor shares, yada, yada, yada. So I'm going to write this as x divided by x plus 4, x minus 5. Minus 5 plus 4 is minus 1, plus 4 minus 5 is minus 20. And 2 divided by x plus 4. And I'm going to bracket that x plus 4 like I was saying earlier. You know, I'm putting those brackets in just so it looks like a unit. It's not necessary to bracket this x plus 4. Right? It's not being multiplied by anything. I just like the way it looks because it looks like the one that's over here. Right, now to identify the lowest common denominator. Maybe you don't need to run this process to find the lowest common denominator here. The lowest common denominator is going to be x plus 4, x minus 5. So this one already is that. In order to make this one that, you need to add in x minus 5 on top and bottom. So I'm multiplying by x minus 5 on top and bottom of that one only. So that gives me x divided by x plus 4 times x minus 5 plus 2 x minus 5 divided by x plus 4 times x minus 5. Awesome. So now I have common denominators. Now that I have common denominators, you can do the addition on the top only. So this gives you, x plus 2x minus 10. So I distributed this to divided by x plus 4, x minus 5. You can combine x and 2x into 3x. And now just take a look, take a second to look to see if there's anything else can be done. 3x minus 10 can't be factored. I like to leave the bottom alone. Just leave it in factored form. Unless there is a situation where you want to FOIL this. I can't, there could be a situation where you would want to FOIL this out. In this case, I would just leave it like this. So this is how I would answer this question. Just like that. Nothing else can be done there. Cool. Well, right on. That's 5. That's 5.2. I think that's long enough for today. The only other thing I want to do is 5.5. Skip 5.3, which is too bad. 5.3 is polynomial division, which it's a really like staple of algebra. If anybody's going to go on to take college algebra, you definitely need to know how to do polynomial division. If anybody's going to go on to do calculus, it comes up. It's not like one of these things that's like, oh, you'll never be able to pass calculus without polynomial division, but it comes up from time to time if you keep studying math or if you're going to be doing some kind of calculatory degree like engineering or where you have to take up higher level math classes. Polynomial division is something that you really should take some time to learn. For Math 105, it's usually in there, but seeing as we missed some time, I think it's appropriate to skip it, which is too bad. It really is. I think it's something that you should learn if you're going to keep studying algebra and math. 5.4 is complex fractions, which I usually skip this one even in a regular semester. It's like something that you should know. You should definitely know how to do it, but can definitely get by without having to spend a lot of time working on it. Section 5.5 is solving rational equations, which is the big picture. So this is definitely even the reason why I'm talking about any of this is so that you can solve equations of this type. So that's what we'll talk about next Monday. And then we'll just call it good on the chapter at that point. There's a lot of other stuff in the chapter that we're axing. 5.6 is some application problems, word problems, which would be really good for anybody that's taking physics or chemistry or biology. You're gonna be doing a lot of stuff like that from 5.6, so maybe it's worth a look. 5.7 is formulas. 5.6 and 5.7 you might want to take a look if you're going to be taking those type of natural science classes. And then 5.8 is about this thing called variation, which we might swing back and talk about toward the end of the semester if we get some time, right? Like the last couple of days of the semester, if we got some time, then we'll do a review of the whole class, and I would like to do 5.8, just like a quick, here's a thing on 5.8. Other than that, that's it. That is it for chapter 5. So we do need to figure out the test. I had a couple people ask about the test situation. At this point, I am thinking my math lab tests are going to be the best way to go. So it's just going to be, it'll feel like a practice test. The only problem having with that is I don't really want to do like a practice test in my math lab and a real test in my math lab, because it's just going to feel exactly the same. So I'm just kind of trying to decide how I want to navigate that, so you don't have to just do the exact same thing twice. But we do have the points for the practice tests. So one of the things I was thinking is maybe I could not do the practice tests in my math lab and do something else so that you can get those 20 points, and then actually do the real 100-point test in my math lab. So from your perspective, if we do it that way, the tests will just feel like the practice tests have felt. You just do a bunch of problems in my math lab. So it'll just be worth 100 points now rather than 20. So I'm still thinking about it. We do need to do the Chapter 4 test as soon as possible. But I'm going to let it breathe for the weekend, and we'll talk about it again on Monday, and I'll have decided what we're going to do. And feel free to give me some ideas if you have any, and if you'd like to provide feedback on how we should if you go about this. So yeah, let me know if you guys have any questions. Talk to you later.